All right, guys, we're going to do some combining functions. We're going to do all these operations that we know how to do. We're going to add and subtract and multiply and divide. And then we're going to do one that's one of something else. So, okay, I don't have my pen down here for some reason. Here it is. Okay. All right, so let's go. Let's work through these together. Okay, f plus g of x. That means I'm going to add f of x plus g of x together. And so I'm going to do x squared minus 9. That's f plus g, so plus x plus 3. And I'm going to work out this way so I can keep it kind of neat down through here. I'm going to combine like terms. This one's pretty easy. This is x squared. I'm going to write my answer in descending order. Plus x. And then negative 9 plus 3 is negative 6. Negative 9 plus 3 puts me to negative 6. So there is f plus g added together. All right, let's do f minus g. We know we have to be a little bit more careful when we do f minus g because of the subtraction sign. So f is x squared minus 9. I'm going to put it in parentheses and put my minus, and then subtract g of x, which is x plus 3. I'm going to distribute the negative sign here. So this becomes x squared minus 9 minus x minus 3, which gives me x squared, and then minus x. And then I have negative 9 minus 3 is negative 12. Okay, so there's our subtraction. Let's do multiplication. So when I do the multiplication of these two, I'm going to do x squared minus 9 times x plus 3. And I need to FOIL. We got to FOIL this out, right? Because when we multiply two binomials together like this, we need to FOIL. So x squared times x is x to the third. Outside 3x squared. Inside minus 9x, and my last two terms, negative 9 times positive 3 is negative 27. Well, that wasn't bad, and I'm already in descending order, 3, 2, 1, 0. So that one's good. Okay, let's do division. Division, we're probably going to be just a little bit harder, so let's see what's happening here. F divided by g. Okay, so this is x squared minus 9 divided by x plus 3. Okay, I want to talk about this because this is a special type of factoring and might be the type of factoring that you're asked to do on the test, but it's really super easy, okay? So this is a binomial. And it's a specialty binomial. And the reason it's a specialty binomial is because 9 is a perfect square. And there's a minus sign here, okay? So this is called the difference of two squares. You're going to want to know this, okay? Difference of two squares, okay? So x squared is a perfect square. 9 is a perfect square. And there's a minus sign in the middle. So that's what you're looking for when you're looking for the difference of two squares. Is this guy a perfect square? Is this guy a perfect square? And is there a minus sign in the middle? And when that happens, what this factors down into, it's still two sets of parentheses. And to get the x squared, I have x and x. And then to figure out what what happens with the 9 is that you take the square root of it. Well, what is the square root of 9? The square root of 9 is 3. So this is a 3 and this is a 3. Well, what are your signs? Well, there's no middle term. There's no B term. That means our outside and inside had to have canceled. So one has to be positive and one has to be negative. So in order for that to happen, that has to go that way. So let me just tell you, this is x squared minus 9. Minus has to be minus. If this is a plus sign, this does not work at all. Has to be the difference of two squares. X squared minus 9 factors down into x plus 3, x minus 3. X squared minus 81, x plus 9, x minus 9. X squared minus 100, x plus 10, x minus 10. X squared minus 16, x plus 4, x minus 4. X squared minus 36, x plus 6, x minus 6. Are you guys kind of seeing the pattern that's happening here with the difference of two squares? There are not very many of these that work like this because there are not all that many perfect squares, okay? But this is what happens when you go to factor x squared minus 9. So watch for this, okay? This type of factoring, because this, you might see this, and this needs to be factored. It's super easy though. This is exactly what happens. You don't have to try to figure out terms or anything like that. Perfect square, minus sign, easy, okay? All right, so that is the numerator factored down. The denominator is x plus 3. Okay. Remember what we talked about is if these are identical, right? Completely identical. They're both x plus 3s. They cancel and leave me x minus 3. Okay. So easy peasy, no problem. All right. Just watch for this special type of binomial right here. Okay. That's the factoring that you might want to be sure you know how to do. Special type of binomials like this. All right. So we need to do f of, let's see, can I hide this? Touching this, yes. Okay, g minus f of 5. Okay, so g minus f of 5. Let me get red here. So g minus f, let's do that and then plug in 5 because this is not too hard to subtract. So g is x plus 3 minus f, which is x squared minus 9. So when I go to simplify this, I get x plus 3 minus x squared plus 9. Okay, so that's negative x squared. Oh, I got to be careful when I plug in right there, right? Negative x squared plus x, and then 3 plus 9 is 12. Okay, so now I'm going to go back in and plug in 5. So negative 5 squared, I got to be really careful here, plus 5 plus 12, negative 25 plus 5, negative 25 plus 5 plus 12, okay? Negative 25 plus 5, that's putting me at negative 20, plus 12 more puts me at negative 8, okay? All righty, one more slide with some function composition stuff.